This question asks us to consider a line angle structure and do several things. How many carbons are there? Label the carbons. How many hydrogens are on each carbon? And then draw the hybrid structural formula. Let's do the first two together. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. There are 9 carbons in this structure, and I've labeled them with orange dots. How many hydrogens are there on each carbon? Every carbon makes 4 bonds. This carbon is already involved in 1 bond, so there must be 3 hydrogens on this carbon. Similarly, 3 hydrogens on this carbon. This carbon is already involved in 3 bonds, so there's only 1 hydrogen here. Likewise, this carbon is already involved in 3 bonds, so it only has 1 hydrogen. This carbon has 2 explicitly drawn bonds, so there are 2 implied hydrogens. The same with this carbon and this carbon. This carbon has 1 single bond and 1 double bond, so that's 3 bonds already drawn in. That means there's 1 valence left to be filled with a hydrogen atom. And finally, this carbon has 1 single bond and 1 double bond. That's 3 total bonds explicitly drawn in, leaving room for 1 implied hydrogen. Now let's draw this in the hybrid structural formula. This will be the hybrid structural formula for this molecule. Notice sometimes the hydrogens are off to the right, sometimes the hydrogens are off to the left, depending on which side of the structure it's on. But what I do want to point out is when we have a bond between 2 carbons, the bond is drawn between those carbons. I don't write CH3 here because then that would have the bond drawn toward the hydrogen, implying the carbon is bonded to hydrogen, but it's not. It's bonded to carbon, and then we put the hydrogens off to the left.